I am going to start with a small problem. Can all of you see the problem? Wait, maybe all of you know it. Those who know it, please, think about it a little bit again. Don't Google it or go to AI and ask this question from AI. If you don't know it, think about the answer. A man travels with a leopard, a goat, and a bundle of grass. Now, the leopard would like to eat the goat, and the goat would like to eat the grass, but the man is preventing them, right? He comes to a river, and there is a boat that can be used to cross the river, but it will only hold the man and one other item. How does he get all three items safely across the river? So think about that for a bit, please. And obviously, if you are going to take one thing, you have to take the goat because the leopard can't eat the grass. You can't take any of the other two because it's a problem. But then when you come back, what do you take next? So the key thing is that you have to bring one of the things back. So you take the grass and bring the goat back, and then you take the leopard, and then you take the goat again. So here it's a sequence. You have to give the clear instructions, very specific instructions to this man how to do this, right? There is no other solution that will work, right? So that's what we really want to see there. And so now if I can get out of this, yes. Let's do another problem. Actually, it's very similar in a certain sense, but it's a different problem, but actually you'll see the solution involves the same kind of thinking. I have hired a man to work for me for 7 days. I have to pay him every day for his day's work. Now I have 1 bar of gold and I can cut it into pieces exactly the way I want. But I can only cut it into 3 pieces. Right? I have to pay him every day for 7 days. But how do I pay him the same amount? Because every day he's working the same amount of work and I want to give him the same amount of money. If I don't give him enough, he won't come the next day. And if I give him too much, he might not come the next day either. So how can you do this? How can you, with cutting this gold bar into only 3 pieces, every day, how can you pay him the same amount for 7 days? To say how you cut the bar and how you make the payment. So some people are getting the answer. Maybe they knew it already. Maybe they are clever. Again, just like the previous example, if you are going to take something across the river, it has to be the goat because the leopard can't eat the grass, right? So here also, you have to clearly you have to give something the first day, exactly 1/7 of the bar of gold. So one piece of the bar should be cut to 1/7. But what do you do how do you cut the other 2 pieces and how do you make this payment? You can't give him 1/9 for a day. How can you give him 1/9? Then you have to cut the bar into 9 pieces. You can't do that. You can cut the bar on only 3 separate pieces. So you must write not only how you cut the bar, but how you make the payment. Think about it. Now do is to say how to make the payment. I will read the solution that people have given. You can cut it into 1/7, 2/7, and then the other piece is 4/7. Then the first day, how do you do it? You give the piece of 1/7. The second day, you give the 2/7 piece, and just like you brought the goat back, then you take back the 1/7 piece. And if you do this, you will see that with this cutting up, you can pay the same amount every day by giving 1 piece and taking another piece back. And build it up so that on the 7th day, again, he gets the 1/7, right? Once again, this solution involved clear instructions, step by step, how to do something, right? I just want now put these to a side. We had 2 problems and we solved them. The solution involved clear instructions, step by step, how to do it, right? Now, we can go to Wikipedia. You are going to learn about computer programming. What is a computer program? So a computer program, don't worry about these words, but if you want, you can go to Wikipedia and look up the meaning of all these words. Everything here that is underlined means that in Wikipedia, if you click on it, it will go to a definition, right? Perhaps maybe I should have translated these two into Sinhala and Tamil. I'm sorry, I didn't do that. Google Translate is good nowadays. But it's a set of instructions and it's a sequence. So you do one instruction, then you do the other instruction, and you do the third instruction. And you have to give the instructions in a programming language, and a computer has to then carry out these instructions, just like we told the man how to cross the river, or we told the other man how to make the payment. Now, when you write a program, you have to design and implement something called an algorithm. And I just want to spend a few minutes now talking about an algorithm, just and because there's some very interesting history coming in. The algorithm is the method of solution, right? So here you go. What is an algorithm? Again, Wikipedia says it's a sequence, again, one after the other, of mathematically rigorous instructions, which means that it is very clear. Sometimes when we use English or Sinhala or Tamil, what we say is not clear to the other person. But when you're talking about an algorithm or a computer program, it has to be exactly clear. The computer has to get the exact message, otherwise there'll be a problem. So this algorithm is something that is used to solve a particular problem. And then once you have that algorithm, you can write it into the computer program. So my question is, were the solutions to our two small problems, were they algorithms? I think they are algorithms, and I'm suggesting that you think of this. This is how you understand what an algorithm is. This very simple thing, which is a child's problem. Maybe all of you have seen the goat and grass and leopard problem. Ultimately the solution is an algorithm. It is a sequence of steps that you have to perform exactly to get what you want. Now I just want to spend 5 or 10 minutes just telling you what the history of the word algorithm is, because this is not something most of you know. Some of you will know. Maybe I should have put a poll up saying how many of you knew about this. Just give me 1 minute, please. So we are going to learn how you get the name. The word algorithm is based on the name of a person. The person is a man named Muhammad bin Musa. He was also known as Al-Khwarizmi, and he lived about 1,200 years ago, as you can see, right? Now, if you write that in English, it means Muhammad, son of Musa of Khwarazm, which is a place in Uzbekistan. That's where he was born. And then he came and worked in Baghdad, which today you know is the capital of Iraq. It was a capital of a very large empire for nearly 500 years. This empire went from Spain and Portugal all across North Africa, all of what we know as the Middle East today, and then Iran, and also countries in Central Asia like what is today Uzbekistan, and so on, right? So the emperors of this empire, they were known as the caliphs. They wanted to develop their empire in terms of technology and science. And when this empire started, the language was Arabic, because that was the language of the Quran, which was the basis of the religion. But there was very little written in Arabic otherwise. So they ordered that every book in the world would be translated into Arabic. They sent people to all parts of the world that they knew. They sent people to India, even to areas of China, and of course to the former Roman and Greek empires, and even to Europe, looking for books in any language, and then they translated them. The people in Baghdad, first they translated the books, Baghdad and many other places. And then once you translate, then you compile them. So, for example, if they translated books on mathematics, they would take a particular branch of mathematics and then write another book saying, 10 different people have said these things. And then once they did that, they learned that mathematics, and then they would criticize and say, no, this is correct, this is wrong. And they would extend the knowledge and come up with new ideas. So in this way, over these, particularly the 200 years from like 760 to 960, they extended the current knowledge of the whole world in mathematics and many areas of pure and applied science, and wrote it all down in Arabic. Now, these books were taken to Western Europe, first to Italy and then to other countries, Spain and France and so on, from the 13th century onwards, and they were translated into Latin. And they were the foundation of advances in mathematics and science in Western Europe, right? So I don't know that, I think now, how many of you knew this story about the contribution of the Islamic empire to what later today we call Western science? There is nothing Western about Western science. It is just science. The whole world has contributed. It is just that the most recent advances, and at least 200-300 years ago, were made in Western Europe. Now, of course, there are advances being made everywhere, first in North America and now India and China and every country in the world. Anyone who knew this story, can someone say yes? Or if you didn't know, type in no. Quickly. Yes. I don't think many of you know it, but those of you whose religion is Islam, might know some of this history. But again, okay, I have here someone who is whose religion is Islam, who doesn't know. So it is unfortunately something that it's not taught in our schools, and that is because the Europeans have basically, without meaning to maybe, but effectively they have not wanted to give the credit to all the other places from which they got their knowledge, right? You can read up about it. There's all kinds of information on Wikipedia. I just thought I just spend this extra time on today because this is something nobody knows about. Now I'm going to talk a little bit, how did his name become associated with algorithms? So his major work, he had many important books he wrote, but his major work is something which I will not read. Now, the first part here is the name in Arabic, and I don't want to risk pronouncing it, but in English, it might be translated as a concise book of calculation by restoring and balancing. Basically, it is a compilation of what they found from all the books they got all over the world about algebra, what we call algebra today. And then, of course, he extends it by making up his own solutions. And the word algebra comes from the title of this book, Al-Jabr, which means in Arabic means the method or the method of calculation. So when it was translated to Latin, right, about 400 years later, or 500 years later almost, it was translated, Liber means book, Algorithmi, that means the book of, then his name, Al-Khwarizmi, was translated to Algorithmi, and then they have made the word algebra already from this word Al-Jabr, and then this Mukabala is this restoring and balancing. You can quickly know what that is. Now we can look at his work on quadratic equations. His methods are algorithms. Then later on, of course, people in Europe took this once the book was translated. And in Europe, finally, the complete solution to the quadratic equation that you know today was developed. But first, they did it step by step for different kinds of problems. So I'm not going to, I will put this PowerPoint on the LMS. But if this is from somebody has been writing, this is what actually he has written, translated into English. In today, we would write x squared plus 10x is 39. But he does not use this notation. That was also invented much later much later, not even in the Italians, by someone in France in the 1600s, right? How to write X and all that. Before that, they had to do it in words. So he says a square and 10 roots. So when he says a square, it means x squared, and root means the root of this x squared, which means x. Everything has to be written in language. And what he gives here is how to solve this equation. Written out here in English, he wrote it in Arabic, right? Now he used the concepts of geometry here. This is how he visualizes his problem geometry. The x squared and then these other pieces and so on. Completing the square is what we do today. This is what he's doing, looking at geometrical figures, right? So here, if you wrote it in English, I mean, not in English, in modern notation, this is the method, right? So what I want to say is that this is an algorithm, right? A step-by-step method of how to solve a problem. So that is why eventually his name was used as the word to describe what today we call an algorithm, right? So you are going to use the word algorithm in your program, and from today onwards, I hope you will never forget how this word came and the history behind it.